Hello, my name is Antoni Ivanov, and today I'm going to talk about applying DevOps practice in the space of data and dataops as a service. Before we dive in, let's talk a little bit about Moneyball. Oh, have you watched Moneyball? This is a really great movie and a book about Oakland Athletics baseball team and its general manager Billy Beane. The story of Moneyball is a real one, starts in the 2000s with Oakland Athletics, a Major League Baseball team faced with budget constraints that severely limited its ability to compete for top talent. So they were in the bottom, right? Bean collaborated with Paul De Podesta, a Harvard graduate with background in economics, to apply statistical analysis to player recruitment. That means that he was looking at players that most of the other scouts were missing because he was using statistics instead of intuitions to make his decisions. Not only that, but during games, he was prioritizing on-base percentage over batting average, understanding that getting on base was often more valuable than hitting home runs. This totally changed the team for just 1 year. In 2002 seasons, Oakland went to win 20 consecutive games, setting American League records. This created a paradigm shift in the entire baseball, where now analytics and data are being actively used by all successful teams. This just goes to prove that good decisions, correct decisions, are generally data-driven decisions, and intuition-based decisions generally don't make it. Today, we're gonna go quickly over our agenda. We're gonna talk about data applications and API for data, what are SLOs and SLOs for data, and the data props for data, and the open source product that I work on, Versatile Data Kit, and how it tries to solve some of the challenges for data engineers. So what are applications? There are many different types of applications, right? We have e-commerce applications where people want to buy things. Of course, there are a lot of mobile applications, iPhone, Android, different IT systems that are used to track different business processes, recommendation system. All those applications have one thing in common. Every single application, it generates data, huge amount of data. Things like databases, which we use to store data about customers, right? Or log files that we use to store a lot of operational data. Click streams about events, about what is happening, how the customer using the product. Metrics, operational metrics to help us maintain our services. One thing that most people don't realize is this data is actively useful and actually being used to create data applications, data analytics. For example, we use all kinds of usage data to be able to understand better how our customers interact with our products in order to make them better. We use business intelligence to understand how a product behave as well to make better data-driven decisions. Uh, Data science teams build machine learning models so that they can recommend uh, the best features about to the customers that they need. Finance team often needs to do forecasting models and so on. Those are all things that rely on this kind of data, let's call it data exhaust, that's produced out of those applications. But data application is also applications. They're simply focusing on data structure slightly different. So what is the usual data journey? I'm going to use, for example, building e-commerce app. The primary function of e-commerce app is to be able to enable customers to buy and sell, to buy products, right? They have product catalog, shopping cart, process transactions, and this kind of data is saved in systems like events are usually saved like system in Kafka or other message queue, in the databases and logs. So if I want to create data applications, I need to ingest the data. That's what we call data ingestion. All these kind of data sources needs to be ingested in kind of analytic system so they can be aggregated, joined into each other. After the data is ingested, we need to ensure that it is accurate, consistent, updated. That's why we need to transform it in a format that other teams now can start use. So our data applications is gonna be also likely be used in other data applications. So we need a good model, sort of like stable model with quality, test it. And then maybe we also, if you want to work in ML training models, we need to do feature engineering, data labeling, data partitioning with real another type of data transformation to create our ML object. And this is used by all kinds of other applications. This could be BI applications to make data-driven decision reports or data-driven on other data-driven products, like recommendation service. This, of course, relies on a lot of data infrastructure that needs to be built, and all of that we call data application. How I think that's the data journey. The data teams are the one that generally responsible for data applications, and some kind of, let's call it infra operations team for this, is the one that sort of provides infrastructure to the data teams. But how do multiple applications communicate between each other? Regardless of talking about data application, API. API is the standard between which any application communicate between each other. What are the API components? First, we have interface and contract. That includes endpoint definitions and the request and response format, whatever it is. This sets how the API is going to be used, right? Of course, we need to make sure the API is secure, authentication, authorization mechanisms, so only people who have right to access the endpoint have access. It's important that API is usable. It's easy, intuitive. It provides client libraries, and the features are easy to use, integrate in other applications. And of course, it needs to be monitored and operated. So logging, monitoring, track usage, manage traffic, and ensure smooth operations are critical. The same thing goes for API for data. But one of the main changes is what's really the usual interface and contract for an API for data. Continuing with our e-commerce app example, so we have two data sources, OTPDB and S3 service, which contains different types of product information. We need to ingest this data, right, to generate copy into a raw data lake. This often lately means databases like Snowflake, Redshift, and so on, not necessarily just Blob storage. And now we still want to expose more of a processed, all combined product view that we guaranteed contains all the necessary product data. So let's call it our product data model, which in this case was got to data sets, but you can imagine it could get much more complex. So where is the API here? Well, with API is communicating between two applications. We have, of course, API between the source applications and our data application. And we need an API between our data application and downstream applications like BI or other software applications and services. Let's focus on the right part. We don't have actually good API for data between the sources and the raw data. And how can we build those? I'll give an example using the right part, but our product data model, but the same thing goes for the API for data needing on the left part. So let's say that we want to create this kind of table or entity of products which contains information about this. So what do we consider API of this kind of product data set? Well, data schema, very important. For example, in this case, this could be the different column names, and the types of each column name are part of the data, basically data schema definitions. What else? Data semantics. Each column name has certain semantics, like name being non-named string representing latest official name. We can notice we need to be as specific as possible. And finally, we need a way to access it. So data access. It could be tables in database using SQL. We could access it by using Python database if data is saved in Parquet or Arrow data formats. So if we go back to our data journey, where do we need API for data? Where do applications communicate? So as we established between the data sources in our main data application, between our data application output, be the data module or the module object, and the BI tools and data-driven products that want to bring any value and insights out of this data. But we can also, of course, think of our data application. It's a huge thing, and we probably want to make it into subcomponents. So probably we need even internal APIs within different components of our data applications, like between the data that's being ingested in raw data lake and the dimension module, or maybe dimension module and the module object that's being created by training the data. So, and this currently is missing. There are no tools, there are no customs for creating API for data. And that's one of the biggest gaps that we have in the data engineering that currently do not exist generally in the software engineering. The goal for here is that the data sources generally in control of the application developer. That's if you are developing any application, service, mobile app, e-commerce app, whatever, you are outputting this kind of data into different as a logs, as database entries in your OLTP database, and those things are going to be used in a data application. So we need to actually put them under API, consider them also an API. What else do we need for this API? Well, we need to have service levels objectives, right? Metrics which guarantee certain promises to the API users. And that's where service level agreements also come. Generally, those come from the data semantics. A large point, once we know the data semantics, we can create rules, and those rules would calculate our data accuracy SLOs. Then we have other more standard SLOs in the data, and like availability SLOs, right? How often the data is queryable. We also, of course, have freshness SLOs, which is very important, that the data needs to be available in the analytic system in 1 hour, for example. It depends. It's important that that our data freshness SLO is the correct one. For some hours, it's okay. For other seconds, it's needed. This both APIs for data and SLOs for data could be also thought about as creating a data contract. There's a lot that's being talked about data contracts currently in the industry. I encourage everyone to go check out the blog post by Chad Sanderson on this link to learn much more about it. They're pretty great. They are deeply into the team. And the third part we want to discuss is DevOps cycle for data. For simplicity, let's sort of flatten out the DevOps cycle. We know the standard DevOps cycle is plan, code, right? The first part, build, test, release, deploy, operate, and monitor. So how do we map the data journey to the DevOps cycle? It's fairly intuitive, right? The first thing you need to do is to plan. So you need to go and discover the data. You need to go and explore the data, find where it is, find, for example, where the product info is kept in S3, is it kept in database, and try to access it. Then you need to ingest it, actually code the ingestions, build the data ingestion pipelines, and probably transform it. Transformation logic, this is another type of code. Transformation logic needs to be encoded usually using SQL or PySpark or something like this, and built in data pipeline. Those roughly go into the plan, code, and build stages, or generally tasks that you do during those stages. Once the data has been explored, ingested, and transformed, it's ready to be deployed for use in reports, analytics dashboards, machine learning modules, or other applications, be it data applications or normal software applications. So we have the whole deploy. We need to test the data after it's or release it, and deploy it similarly as we do in the data DevOps cycle. And of course, we need to maintain it. It must be consistently managed to ensure it stays accurate, secure, and available, similar to how applications operate in monitoring DevOps environment. Let's call this managed data. Now that we sort of covered all the aspects of how do we apply DevOps for data, API, slos, and DevOps cycle, I want to introduce Lifestyle Data Kit. It's an open source framework which provides solution for users to have self-service environment for data engineers to create end-to-end data platforms using this kind of code-first, decentralized, fully automated way. Its focus is more on the DevOps part and the data journey part. But let's see. So it provides really two things. One is the SDK or a framework, almost you can think it Spring for data, which you can allow you to develop data jobs using either Python, so you have some methods to extract and load data, or SQL. You can do things like parameterized transformations. And it allows also to deploy and monitor using control service and operations UI this data and data applications that you're building. We call them here data jobs. Looking at the data journey, Versatile Data Kit ultimately flips the ingestion and transform part. It can be used also to train data models, and generally you can use to export data. In itself, Versatile Data Kit is a framework, so it allows you to write the code that you need to ingest, transform, train, export the data, and integrates with different databases, which can like Snowflake, Impala, Postgres, MySQL, or different compute engines you can use, like a Spark link to actually make the heavy lift computations. A lot of focus has been meant to simplify and enhance complexity of data infrastructure and generate DevOps for the data teams as much as possible. So it allows you to basically plug in between data infrastructure and the data applications, allowing a lot of control both over the DevOps cycle and over the monitoring aspects and the infrastructure to the sort of infra operations team. So the data teams can focus only on data and don't worry much about the software part. So for example, let's show a quick demo of what I mean. Let's say that we have this kind of databases and the data teams are developing their data application, running SQL queries, and maybe they're running such big SQL queries that are breaking the database. Oh, that's it. So what do we do? Well, we have to either block the data team or ask them to stop. Would be much nicer if instead of finding out this when those queries land production, we find it during developer time, as early as possible. And that's what you can do with Versatile Data Kit. Let's say the data team is here developing their job, running this kind of SQL queries and account from uploads, and using all kinds of different methods. What completely data teams, without even knowing, though of course they'll know, the platform team or infrastructure operation team or data central team could develop this kind of VDK query validation plugin. Could be as simple as compare the size of a query, or it could be much more complex, like doing some kind of analytics on the query. It doesn't matter, because VDK allows you to intercept both the data and the metadata in plugins. You can intercept each query statement and decide what to do with it through plugin. In this case, let's say that we reject all queries bigger than 1000 expressions or 1 megabyte. Then, while the data user and data team is developing their job locally, they'll complete the error immediately. The query wouldn't leave their local environment. I don't think there's a huge benefit to be able to do this very quickly. This type of query validation can be used to enforce data quality rules and data APIs, basically, as early as possible at the data at the query when the query is being developed, basically when the data model is being created. And that's pretty powerful. Now let's look at more of the DevOps, the operations and monitoring and deployment part, not just in the development part. So how can we help with the deployment part? So yeah, let's go back to our DevOps cycle. What we want to do is enable infrastructure operators or centralized data team to sort of have this kind of more control over how the data applications, the data jobs are being built and even tested, how they're being released and deployed, because there are a lot of concerns. You have to think about version, you have to be containerization, you have to think about adding metrics, metadata, and so on, creating Docker images, creating cron jobs or Kubernetes objects. This all should be completely hidden out for data engineers and data users, because you want them to focus on more data modeling and applying business insight, applying business transformation insights on the data, and not to worry about this kind of all these kind of software engineering concerns, DevOps concerns, and that's very important for them. So data teams focus on planning and coding data applications. Of course, they need some way to monitor their data. While the, let's call it IT team or whatever, the small DevOps team, who can establish policies through this kind of extensibility mechanism the VDK provides. What policy? Well, let's look at example. Very simple example. The way, by default, right, VDK also install a kind of dependency package the data team job ready for automatic executions in a cloud environment. In VDK case, it's using Kubernetes. But let's say that we want to make sure that we had some standardized system tests for all jobs that verify certain quality or certain API contract or certain metrics. We can do this very simple, right? Everything, the way plugins are built in the control service are through Docker images. Basically, we can extend a style data kit job with a Docker image. Well, at anything. You can run system tests. You can remove execution privileges. And this script is being run during the build and test phase. So before anything is released and deployed, after the job is being built, they can run this kind of test and change the job scripts by this way guaranteeing certain level of quality. So if the system test failed, the job wouldn't be deployed, and security by removing unnecessary permissions. In summary, what do we think about by DevOps for data? Well, one spec is API for data, right? API for data means we need data schema, we need data semantics defined, we need some kind of validations and documentation that people can explore the data, right? They need to be able to access it easily, find out where it is, explore it. It needs to be as well documented as any normal API. We need slos and SLAs for data. So we need to be able to collect metrics about the data. Things like freshness, things like unique values and so on. And there are a lot of metrics. And we need the data to follow the DevOps automated DevOps cycle. Basically, the whole pipeline from sources to insights should be automated using the best DevOps practices, which means ability to plan code, injection transformation logic, ability to deploy that logic, and to manage it, to operate it. Versatile Data Kit actively helps in a lot of those, especially in the DevOps for data part. It also, through plugins, could help, as we discovered, to create and enforce API for data SLS. No, this is really direction that we need a lot of more research and a lot of more work to do in Versatile Data Kit. So it will be really helpful if anything that you find interesting here, if you'd like to learn more, just get in contact with us. Yeah, you can do this by going to the GitHub repo and starting a discussion, contacting our Slack channel, writing an email, or contact us on LinkedIn. And there are a lot of work to make sure that data engineering practices are able to adapt and adopt good software engineering and DevOps practices. A lot of this was discussed is what it would be nice for data engineers to have already, and it's still missing. The hours we started, we tried to bridge the gap. We know that we have a lot of work to do, and your input, anybody's input, would be extremely valuable. I hope you get in contact with us, and thank you again for listening to these 30 minutes of me talking, and have a nice day or night or whichever part of the you are.